Good morning, friends. Last we discussed about Bohr's atomic model because the Rutherford's atomic model cannot explain the stability of an electron. Thus, the Neil Bohr in 1913 introduced the three hypotheses which are added in Rutherford's atomic model. So, today we are going to discuss about what is the radius of nth orbit of an electron using Bohr's model and what is the total energy of an electron in nth orbit with help of a hypothesis suggested by the Neil Bohr. So, the question is that using Bohr's atomic model and obtain equation of radius of nth orbit of an electron. For that purpose, we consider the electron is revolved around the nucleus in circular orbit. This orbit is the stable orbit. Small central region that is known as the nucleus. Nucleus having the charge is Zd. Z is the atomic number of the element and R is the radius of this orbit. Here we consider there is the nth orbit. Therefore, the radius of nth orbit is Rn. Electron is revolving this nth orbit with orbital speed or the orbital velocity Vn. We are interested to obtain the equation of radius of nth orbit. Right? For that purpose, we consider that H shown here. Suppose mass of an electron is M, charge E, linear velocity or the linear speed in nth orbit is Vm and radius of nth orbit is Rn. The charge of the nucleus is Zd, where Z is equal to atomic number of element. So that is the description of the figure. X1 in figure, suppose mass of an electron M, charge E, linear speed or the linear velocity in nth orbit is Vn and radius of the nth orbit is Rn. The charge of the nucleus is Zd, where Z is the atomic number of element. Now we know that in uniform circular motion, already we learned in Newton's standard. When the particle is revolved on a circular path, the necessary centripetal force is required. Or the force acting on a particle is centripetal force, its value is mv square upon r. So here, the electron is revolving in circular orbit. Therefore, the necessary centripetal force is provided by the Coulombian attractive force by the nucleus on this electron. And due to that result, the Coulombian force of attraction exerted by the nucleus on an electron is towards the nucleus, which provides the necessary centripetal force. So, for that purpose, the necessary centripetal force is provided by Coulombian force of between electron and nucleus. Therefore, we can write the centripetal force mvn square upon I is equal to 1 upon 4 pi epsilon 0. ZE is the charge of the nucleus into E upon Rn square. 1 times iron cancelled. Therefore, mvn square is equal to 1 upon 4 pi epsilon 0 Z square upon Rn. Right? Now, this equation, what is the equation of velocity? What is the equation of velocity? For that purpose, we have to use the second hypothesis suggested by the Bohr. That is our equation number 1. Here, Bohr's second hypothesis. Angular momentum of an electron is ln. ln is equal to mvn Rn is equal to nh upon 2 pi. nh upon 2 pi. That is the equation. That is equation number 2. Now from equation 1, this equation we can add in that form Vn into mVn, and this Rn is taken here. Rn is equal to 1 upon 4 pi epsilon 0 Z square, or the Z square upon 4 pi epsilon 0. Rn is taken here. Right? Now we substitute the value of each second equation. Putting equation 2. That is the value of angular momentum mvn I. Therefore, Vn into bracket nx upon 2 pi is equal to Z square upon 4 pi epsilon 0. 4 pi epsilon 0. Now, therefore, Vn is equal to Z square upon 4 pi epsilon 0 into this term nh upon 2 pi is taken this side. Now, this term nh upon 2 pi is taken this side. Therefore, there is reciprocally multiplied 2 pi upon nh. These 2 pi is cancelled with this 4 pi 2 is remaining. So it's equal to 1 upon n. 1 upon n Z square upon 2n 2h epsilon 0. Thus, we obtain the orbital velocity of an electron in nth orbit. Therefore, Vn is equal to 1 upon n into Z square upon 2h upon epsilon 0. Therefore, Vn proportional to the Z upon n. Because here E to H epsilon 0 are constant. Therefore, Vn is equal to this. That is the equation of velocity of an electron in nth orbit. In nth orbit. Clear this? There is the equation number 3. So now Vn is equal to Z upon n, which represents that the velocity of an electron in nth orbit is false by n. Thus, value of Vn is false by n. For hydrogen, you know, Z is equal to 1, therefore Vn proportional to 1 upon n. Thus we obtain the equation of orbital velocity of an electron in nth orbit. But our aim is to find out the equation of orbital radius in nth orbit. For that purpose, here again we turn back in this equation. Equation 1. Right? Well, in this equation also we can add Rn is equal to, from equation 1, our value is this, mn square. Instead of this, we add the equation Rn is equal to Z square upon 4 pi epsilon 0 into mvn square. Again, we substitute the value of from equation 1. This equation is written in terms of iron taken here. Therefore, Z square upon 4 pi epsilon 0 mvn square taken here. Substitute the value of equation 3. From equation 3, substitute Vn square. Therefore, Rn is equal to Z square upon 4 pi epsilon 0 Mn. Now, value of Vn square. So, there is a Z square E is to 4 upon, there is reciprocal multiply n square 4 h square epsilon 0 square. 1 times epsilon 0 cancel. 4 cancel. E square is cancelled with e is to 4. Right? Therefore, n square epsilon 0 n square epsilon 0 z cancel upon mn m pi z square. So remaining is n square epsilon 0 upon m pi z square. There is the equation of radius of nth orbit. Radius of nth orbit. There is an equation by 5. Thus, radius Rn is directly proportional to the n square. Rn proportional to the n square. Right? So there is the equation of radius of the nth orbit in nth orbit. For hydrogen, you know, Z is equal to 1, therefore Rn is equal to n square h square epsilon 0 upon m pi square. M pi square. There is the equation of radius of nth orbit for hydrogen. Okay. Again, we need, because that's the most important question frequently asked, obtain the equation of radius of nth orbit and also the total energy of an electron in nth orbit. Now, our question is that using the Bohr's atomic model and obtain the equation of radius of the nth orbit of an electron. For that purpose, it's shown in the figure. Suppose the mass of an electron is m, charge is e, and linear velocity in nth orbit is vn. And radius of the nth orbit is ion, and charge of the nucleus is Zd, where the Z is the atomic number of element. The necessary centrifugal force is provided by Coulombian force of attraction by the nucleus and the electron. Therefore, centrifugal force mvn square upon ion is equal to Coulombian force of attraction 1 upon 4 pi epsilon 0 Z into E upon ion square. 1 times ion cancel. Right. Therefore, we obtain mvn square is equal to 1 upon 4 pi epsilon 0 Z square upon Rn. Then the equation. From Bohr's second hypothesis, angular momentum of an electron is ln is equal to mvn ion is equal to nh upon 2 pi. Now from equation 1, take the ion here, and instead of mvn square, we can add the mvn into vn into ion. Therefore, vn is out of the bracket. Inside the bracket, mvn ion is equal to z square upon 4 pi epsilon 0. From equation 2, what is the value of angular momentum? mvn ion is equal to nh upon 2 pi. Here we substitute the value of this. Therefore, vn into nh upon 2 pi is equal to z square upon 4 pi epsilon 0. Therefore, vn is equal to z square upon 4 pi epsilon 0 into 2 pi upon h. Therefore, 1 upon n into z square upon 2h epsilon 0. Here E common, E is a constant, Z constant, H constant, epsilon 0 constant, and 2 constant. Therefore, Vn proportional to Z upon n. Z is depends on the number type of element. If the element changes, the value of Z is 6. Therefore, the velocity of electron in nth orbit is 4 pi n. That means the Vn proportional to Z upon n. Now for hydrogen atom, substitute the n is equal to 1, therefore Vn proportional to the 1 upon n. Therefore the velocity of an electron in nth orbit is inversely proportional to the orbital number. Now we are interested to obtain the equation of radius of nth orbit. For that purpose, from equation 1 is this: mvn square is equal to 1 upon 4 pi epsilon 0 z is square upon I. Therefore, I is equal to 1 upon 4 pi epsilon 0 z square upon mvn square. We substitute the value of vn square from equation 3. Therefore, I z square upon 4 pi epsilon 0 as it is into m. Now, value of vn square, z square is 3:4. Now, in denominator comes into the numerator n square 4h square epsilon 0 square. Therefore, we obtain Rn is equal to n square s square epsilon 0 upon m pi z square. Right? So here Rn is directly proportional to the n square because this part is constant. Therefore, for hydrogen atom, Z is equal to 1. Therefore, Rn is equal to n square epsilon 0 upon m pi square. Right? Okay. Now just read here, the equation of radius of nth orbit is I is equal to n square s square epsilon 0 upon m pi z is square. That is the equation of radius of nth orbit. Now for hydrogen atom, substitute the Z is equal to 1. Therefore, Rn is equal to n square h square epsilon 0 upon m pi e square. M pi e square. The side of innermost orbit of the nucleus or of the atom is known as the Bohr radius and is represented by A0. The side of innermost radius n is equal to 1 is known as Bohr's radius. It is represented by A0. Therefore, R1 is equal to A0, that is the Bohr radius, is equal to n is equal to 1. Therefore, h square upon into epsilon 0 upon m pi is square. N is substitute the value of h epsilon 0 m pi and e. We obtain m pi and e. The Bohr radius R1 is equal to A0 is equal to 5.29 into 10 is to minus 11 meter. That is approximate 0.53 angstrom. 0.53 angstrom. So that is the value of the Bohr radius, or the value of first orbit of hydrogen atom. Clear? Again, the radius of the nth orbit for any element is represented by this equation: n square is epsilon 0 upon m pi z square. For hydrogen atom, substitute the z is equal to 1. Therefore, Rn is equal to n square epsilon 0 upon m pi square. The side of innermost radius, that means the first orbit, n is equal to 1, is known as Bohr's radius. It is represented by A0. Therefore, in this equation, we substitute the n is equal to 1. Therefore, R1 is equal to A0 is equal to, instead of the n1, therefore 1 square h square epsilon 0 upon m pi square. Substitute the value of h epsilon 0, m mass of an electron, pi, and e charge of an electron. We obtain the Bohr radius R1 is equal to A0 is equal to 5.29 into 10 is to minus 11 meter. Therefore, 0.53 angstrom. Now the next question is that accept the equation of radius of nth orbit and obtain the equation of total energy of an electron in nth orbit. So the question is that accept equation of radius of nth orbit Rn is equal to n square h square epsilon 0 upon m pi z square, and obtain expression of total energy for an electron in nth orbit. Already we did this equation, but here we are using the concept of the Bohr's hypothesis, and also using this equation we derive the total energy of the equation in nth orbit. For that purpose, again we assume that the electron revolve in nth orbit around the nucleus. Nucleus having the charge is Zd. Nucleus having the charge is Zd. That is the electron. Having the mass and charge is E. So its orbital velocity is Vm and radius is R. Radius is R. The Coulombian attractive force exerted by the nucleus on an electron is towards the nucleus, which provides the necessary centripetal force. So, as shown in figure, suppose mass of an electron m, charge E, velocity in nth orbit Vm, and radius of nth orbit is I, and Ze is charge of nucleus. Charge of the nucleus. When Z is atomic number of element. Said is earlier, the necessary centripetal force is provided by Coulombian force of attraction between nucleus and electron. The necessary centripetal force is provided by the Coulombian attractive force between electron and the nucleus. Then centripetal force m square upon r, mvn square upon rn is equal to Coulombian force of attraction 1 upon 4 pi epsilon 0 Ze into E upon Rn square. This I one times cancel. Therefore, kinetic energy of an electron is half m Vn square is equal to k, kinetic energy. So multiply both sides by 1 by 2. Therefore, half m Vn square is equal to Z square upon 8 pi epsilon 0 R. 8 pi epsilon 0 R. Clear this? Okay. So this is the kinetic energy of electron in nth orbit. There is an equation, and the potential energy there is a U is equal to Coulombian attractive force Fe into R Fe into R. And negative of Coulombian force or the electrostatic force into distance. So it's equal to minus K Q1 Q2 upon I. But in our case, Q1 is the charge of the nucleus J, Q2 is the charge of an electron, and radius is I, and K is equal to 1 upon 4 pi epsilon 0. Therefore, minus 1 upon 4 pi epsilon 0 ZE into E upon I. So, potential energy U is equal to minus Z square upon 4 pi epsilon 0 Rn. That is equation 2. That is equation. Therefore, total energy of an electron is the addition of kinetic energy plus potential energy. Substitute the value. Kinetic energy is Z square upon 8 pi epsilon 0 Rn plus potential energy U. U is equal to minus, therefore minus Z square upon 4 pi epsilon 0 Rn. Now listen, in both equations, this part is common. Therefore 1 upon 8 minus 1 by 4. 1 by 8 minus 1 by 4. Subtraction is minus 1 by 8. So E is equal to minus Z square upon 8 pi epsilon 0 Rn. That is the equation of total energy. Clear it? Okay. Now substitute the value of, there is a equation number 3. Substitute Rn is equal to n square epsilon 0 upon m pi z square. M pi z square. Therefore, we obtain the equation of total energy En is equal to minus z square upon 8 pi epsilon 0. Now in denominator term I, therefore this part is in denominator n square h square epsilon 0. Now this part is in numerator m pi n square h square epsilon 0. Here m pi z is square. Right? Okay. Therefore the pi is cancelled. Only. What is the remaining? So remaining is that minus m z square is equal minus m z into z square into e is to 4 upon 8 n square h square epsilon 0 square 8 n square h square epsilon 0 square is the total energy of an electron in nth orbit. Is the equation of total energy of an electron in nth orbit. Here the total energy is negative. It represents that the electron is in bound with nucleus. Negative sign indicates the electron is bound with the nucleus. Again, how we obtain the total energy of an electron? So question is that accept the equation of radius of nth orbit Rn is equal to n square epsilon 0 upon m pi z square. Sometime in exam equation is not given, then the question is given. Accept the equation of radius of nth orbit and obtain expression of total energy of an electron in nth orbit. Or question is also asked like that way, using the Bohr's hypothesis or the Bohr's concept of atomic model, obtain the expression of total energy of an electron in nth orbit. For that purpose, here the figure, the nucleus having the charge is Ze, electron is revolved in nth orbit with linear speed or the linear velocity Vn and orbital radius is I. mass of the electron is m, charge of an electron is e. Z is the atomic number of the element. That is this guy. Now, the necessary centripetal force is provided by the Coulombian force of attraction by the nucleus on the electron. That is written here. The necessary centripetal force is provided by the Coulombian attractive force between electron and the nucleus. Therefore, the centripetal force m square upon I is equal to Coulombian force 1 upon 4 pi epsilon 0 Zd. That is our q1 e, our q2, and this square of the distance I square. I cancel. We obtain m square is equal to 1 upon 4 pi epsilon 0 Zd square upon I. Now we require the equation of the total energy of an electron. Therefore, total energy of an electron is equal to addition of kinetic energy plus potential energy. For that purpose, the kinetic energy of an electron is half mvn square. We substitute the value or we multiply both sides by half of this equation. Therefore, Z square upon 8 pi epsilon 0 Rn. That is kinetic energy of electron in nth orbit. Now, potential energy U is equal to electrostatic force into distance. Electrostatic force is minus k q1 q2 upon I square into I 1 times I cancel. Therefore, only the ion in denominator. But here q1 is Zd, q2 is E. Therefore, minus 1 upon 4 pi epsilon 0 Zd into E upon I. So it is equal to minus Z square upon 4 pi epsilon 0 I. Therefore, the total energy of an electron is equal to K plus U. Therefore, substitute the value of K and E. K is kinetic energy, Z square upon 8 pi epsilon 0 Rn. Right? And potential energy is this. Minus Z square upon 4 pi epsilon 0 Rn. In both terms, Z square upon pi epsilon 0 Rn is common, taken out, therefore 1 upon 8 minus 1 by 4. So there is a minus 1 by 8, therefore Z square upon 8 pi epsilon 0 Rn. Now we substitute the value of Rn, n square epsilon 0 upon m pi Z square. So after simplification, the total energy of an electron in nth orbit is minus m square Z square is to 4 upon 8 n square epsilon 0 square. Now just read the equation of total energy of an electron in nth orbit En of an electron in nth orbit is En is equal to minus m Z square is to 4 upon 8 n square epsilon 0. Right? Okay. So from this equation here, mass m constant, E constant, N constant, H constant, and epsilon 0 constant. Therefore, En proportional to the minus Z square upon n square. For hydrogen atom, taking Z is equal to 1, taking Z is equal to 1. Therefore, En is equal to minus m is to 4 upon 8 n square h square epsilon 0, which is total energy of an electron in nth orbit for H atom for the hydrogen atom. Okay. Now substitute value of M E N is equal to 1, H and epsilon 0. Right? Last we substitute the N is equal to 1. Therefore, M, E, H and epsilon 0. Therefore, the energy in orbit En is equal to minus 2.18 into 10 is to minus 18 upon n square in joule. But we know that 1 electron volt is equal to 1.6 into 10 is to minus 19 joule. To convert this energy in electron volt, we have to divide this term by 1.6 into 10 is to minus 19. Therefore, En is equal to 2.18 into 10 is to minus 18 divided by n square into 1.6 into 10 is to minus 19. That was electron volt. Therefore, total energy of an electron in hydrogen atom in nth orbit is equal to minus 13.6 upon n square electron volt. Right? Therefore, the total energy of an electron in nth orbit for hydrogen atom is minus 13.6 electron volt. Again, the total energy of electron in nth orbit is En is equal to minus m z square e to 4 upon 8 n square h square epsilon 0. So from this equation, the total energy of an electron is directly proportional to the z square and inversely proportional to the n square. For hydrogen atom taking z is equal to 1, therefore En is equal to minus m e to 4 upon 8 n square h square epsilon 0. Energy of electron in nth orbit, which is the total energy of electron in nth orbit for hydrogen atom. Now we substitute the value of mass of an electron, charge of an electron, Planck's constant and epsilon 0. We obtain En is equal to minus 2.18 into 10 is to minus 18 joule upon n square. To convert into electron volt, we know that 1 electron volt is equal to 1.6 into 10 is to minus 19 joule. So divided this energy of joule by 1.6 into 10 is to minus 90. So we obtain the energy of electron in the nth orbit is minus 13.6 upon n square for hydrogen atom. And from this, the energy of the orbit Bohr's radius, energy of electron in Bohr radius is minus 13.6.